can give the talk without the slides, and if the slides come up, we'll use the slides. So, Kunal kindly invited me to give a talk to talk about how scientific theories could interact with the Indian knowledge systems and I think spiritual systems more generally. And one key point is that many spiritual traditions have said for thousands of years that the words that we use to describe spiritual ideas are merely pointers. They're not the truth. And they're very, very careful to point out that these, whatever you say is a pointer to the truth, but it's not the truth, and to be very, very careful about not thinking that you have the final statement of anything. And in science, we have the same kind of idea, that scientific theories are just theories. They're not the truth. And when we talk in science about scientific theories of everything, that's only with a wink and a nod. No one actually believes that we could ever get a scientific theory of everything for very simple and principled reasons. A scientific theory has a set of propositions, truth value statements. Some of them we call the assumptions of the theory, and the others are the statements that we then try to explain. So we have assumptions and then explanations. And so on the face of it, a scientific theory can never be a theory of everything because it never explains its assumptions. It assumes its assumptions. So it's a theory of everything except its assumptions. Now you can say, well, that's not a problem. I'll give you a deeper theory that has an explanation of those assumptions of your theory. Indeed, you can. And indeed, that's what science is about, getting ever deeper theories that can explain the assumptions of prior theories. But your new theory will, of course, be a scientific theory with its own assumptions. And this goes on ad infinitum. So ultimately, what we see in science is the same thing, that scientific theories, like spiritual descriptions, are merely pointers. They can never be the final theory of everything. They're merely pointers. So why do science? The reason we do science and what science is really good at is the following. When we say that our words in spiritual traditions or science are just pointers, what we're saying is that there is a scope and a limit to the explanations of our theories. There's a scope and a limit to what we say in spiritual terms. There's always a scope and a limit to what we say in any scientific theory. The power of scientific theories is that a good scientific theory gives you tools, mathematically precise tools, to explore its scope, to see what it can do. Like Einstein's theory of special relativity gives you a wonderful theory of space-time and his theory of general relativity of gravity, incredible scope. And his mathematics gives you the scope to actually understand that it transformed the world. That's a good theory. A great theory gives you the mathematical tools to find its limits. And that's where the spiritual traditions, they will tell you that there are limits, but they don't have the tools to find out precisely where those limits are. The scientific theories do. So in the case of Einstein's theory, his theories gives you all these amazing things that we can do. I mean, our GPS system is based on Einstein's theory of gravity and so forth. It's amazing what it can do. But it also tells us where it stops. Einstein's theory of space-time falls apart. It falls apart at 10 to the minus 33 centimeters and 10 to the minus 43 seconds. We know precisely where his theory falls apart. So it's not just a good theory, it's a great theory because mathematics of Einstein's theory says it's wonderful, it'll give you GPS, it'll give you all this wonderful stuff. Oh, yeah, so I actually did prepare it. Okay, so this, as I was saying, the theory has things that it assumes and things that it explains, and so there's no theory of everything. So, but the nice thing about science is that it tells you precisely, a great theory tells you precisely where it falls apart. And that's what we need. That's the kind of benefit that science could bring to taking spiritual ideas and turning them into mathematics. Doesn't mean that we've now turned them into something that's the final word. It's just another theory. But the advantage is it's a precise theory. So here's a bunch of things that a theory of consciousness needs to explain. qualia, free will. I mean, it's a laundry list. And of course, we don't. You would want to use Occam's razor. We don't want to assume everything. We'd like to assume as little as possible. So good scientific theory says assume as little as possible and explain as much as you can. And so what we're doing in our theory of conscious agents that Kamal mentioned is we're taking two out of this. Qualia, there are conscious experiences, and action, which I'll just say there are probabilistic relationships among conscious experiences. That's awesome. We're not assuming learning, memory, intelligence, attention, all this other stuff. We'll have to build a theory of all these other things using only the qualia and the actions. That's the task we do ourselves. Assuming only that there are experiences and probabilistic relationships among experiences do all of this other stuff. The way we try to do this is in a formal model of something we call a conscious agent. And there are the experiences. No, I don't, there's no point. Okay. So the experiences, based on, so there's the experience of the agents. It could be like red, green, and blue, for example, a very simple agent. I have just red, green, and blue. Based on those experiences, decides what action it's going to take. Those actions probabilistically affect the experiences of a bunch of other agents. Think of this as a vast social network, like Twitterverse or something like that. So you're tweeting what you've experienced and tweeting it off to others, and they're getting the experiences. And then the network itself affects your experiences. And so you get this loop. And it's a vast social network. Mathematically, the spaces of experiences are probability spaces. So there's a precise mathematical formulation of this. These are probability spaces. So anything in a circle is a probability space. And anything with an arrow is a Markovian kernel. It's a linear operator that transforms probability measures to probability measures. So forth. So this is a precise, I mean, I've just put it without the mathematics, but this is all a precise mathematical model. And the nice thing about it is it's trivial to show that it's computationally universal. So anything you can do with neural nets, you can do with networks of these conscious agents. So that whole laundry list that I gave you, we can do. And it's also beyond computation. Right? So it turns out that when you look at the details of the structure of these Markovian kernels and so forth, you're not limited to computation. So you can give theories of learning, memory, problem solving, the whole bit. You can build them out of this simple model of conscious agents. So that's the idea. Minimal, there are assumptions, there are conscious experiences and probabilistic relationships. That gives you more power than neural nets, so you can build models of learning, memory, attention, the self, consciousness, and so forth. So in this framework, then reality is not space and time. And in fact, Einstein told us it can't be space and time. Space and time fall apart at 10 to the minus 33 centimeters and 10 to the minus 43 seconds. So space-time and its objects cannot be fundamental. And work that I've done with Chetan Prakash and others using evolution by natural selection comes to the same conclusion. Space and time cannot be fundamental. So our best theories tell us that first, the physicalist assumption has been fantastic in science and has been the foundation of all the technology we're seeing here. And it has a hard limit, 10 to the minus 33 centimeters. That's the end of it. And what's happening is, I'll just mention, that there are a lot of new theories being developed of physics outside of space-time, called positive geometries. So the idea is that space-time then is just a headset. Space-time is just a user interface that certain conscious agents use to simplify their interactions with other conscious agents. And it's just one of an uncountable infinity of possible headsets. There's nothing special about space-time. It's probably one of the more trivial headsets that's available to us. So, so what would be an advantage of having a scientific theory of consciousness and to spiritual traditions? One advantage would be that spiritual traditions, without a scientific theory that's mathematically precise, it's hard to make mathematically precise predictions. You can do experiments, but the scientist is always going to ask you, how does your experimental data match your precise predictions? I'd like to see 5 or 6 decimal places. How many decimal places do you predict, and how many decimal places do you get? And right now we don't have such a thing. So the idea is to get mathematically precise predictions Because if you can actually predict something that the scientists can't predict, and you get it right, then they'll pay attention. Until then, they won't pay attention. If you don't make a prediction that's mathematically precise, you will never get the attention of science. Just that simple. So you have to have a mathematically precise prediction, or you're not in the science, and it will never make a dent. So what we can do is take this whole loop, the decision, the action, and perception, and make a single Markov kernel. One nice thing about Markovian kernels is that you can combine them together, and I'll call this the qualia kernel. This is, I have an experience now. What's the probability that I'll have an experience in my next now? If I see red now, what's the probability I'll see green or blue next, and so forth. So this is all, what are my sequences of experiences in the now? That's what that qualia kernel does. So it actually can model the now and the changing experiences. We work on doing with a number of collaborators, but you know, I mentioned Chaitan, but there's a number of collaborators on this. We're working on how do we find map between these conscious agent dynamics, this network of conscious agents, and physics. And our proposal is this, and we've published this, that particles in space-time, bosons, leptons, and quarks, are projections of recurrent communicating classes of these Markovian dynamics. So it's a precise proposal, no handbook. And here's an example of a Markovian kernel, and I've highlighted in colors the various recurrent communicating classes. And there's other, we can make a little, here's communicating classes up here. We can have free particles, bound particles, and confined particles. We have some ideas about how to correspond with them. And we've got a little intruder here. And then we proposed this correspondence between physics properties on the left and properties of conscious agents on the right. So mass. What is the mass of a particle? No hand wave. We propose is precisely the entropy rate of the recurrent communicating class. No hand wave. That's it. If we don't get the right answers mathematically, then we're wrong. So it's a no hand wave proposal. Momentum is a function of the number of states in the recurrent communicating class. The spin is a function of the determinant, and the distance is a function of commuting times. So we're proposing precise mappings between properties of the conscious agent realm and space-time. So to wrap it up, we're going to be doing experiments where we try to model the dynamics of protons, the innards of protons, the quarks and gluons inside protons, and try to model their momentum distributions. But I'm going to mention, I'll close with this then. I mentioned Einstein. Einstein assumed at the start of his theory of space-time that the speed of light is the same for all observers. Doesn't matter how fast you're moving, the speed of light will be the same. Now that was one of his assumptions. He didn't explain it. He doesn't explain why the speed of light is the same for everyone. He just assumes it, and then you get special relativity. So what would we want from a deeper theory that goes outside of space-time? We would like to explain why is the speed of light the same for all observers. That would be a really nice thing. So I think we can. Again, the idea comes from what I said earlier, that the entropy rate corresponds to mass and the commuting times correspond to distance. It turns out when the entropy rate is 0, you get Markovian kernels like this that have only zeros and ones in them, and they have necessarily the fastest commuting times, and it's always the same commuting time. When you have non-zero entropy rates, you get kernels like this, and what we see is that yes, when you get to 0 entropy rate, then the commuting times are always exactly the same. So speed of light is the same for all observers, and also you see that that only happens when you are massless. So this is, we haven't published this yet, but this is the kind of thing where you're trying to no hand wave, make predictions, and actually get something that's deeper than the physicals. So our goal is not simply to get experiments that challenge the current physicalist paradigm. Our goal is to get a theory that completely transforms everything by giving you a deeper explanation than the physicalist theories. that actually shows that their assumptions are something that we can actually explain. We don't have to assume the speed of light is universal. We can explain why it's universal from a deeper theory. So the goal is to explain everything the physicalists explain and more. And then, and only then, will science listen to spirituality. Challenge the current physicalist paradigm. Our goal is to get a theory that completely transforms everything by giving you a deeper explanation than the physicalist theories that actually shows that their assumptions are something that we can actually explain. We don't have to assume the speed of light is universal. We can explain why it's universal from a deeper theory. So the goal is to explain everything the physicalists explain and more. And then, and only then, will science listen to spirituality. Thanks for one or two questions, I
We
think.
still have time, and we'll have to take a couple of questions first. We may not be able to have the panel as we planned, but I still reserve the right to ask the first question that I would have asked as part of the panel. Then I'll offer opportunities to everyone. So, Don, thank you very much, and thanks for your collaboration with our teams, and looking forward to getting working together more. You've kindly sat through the whole workshop, and I just wondered if there was aspects of what you had heard during this workshop that might be possible areas for collaboration or development, and particularly looking at it from a mathematical point of view.
Yes.
So I'm looking for some reflections on our own workshop.
Right, and I should say that Kunal and I and his team, and my team, already have a date scheduled for us to actually start a collaboration. So we're actually in a couple of weeks going to be starting to talk turkey about how to do things. But for example, the notion of Maya that came up here today is very, very similar to, well, I could look at it two different ways. I could either say it's like the headset, but I think it's even more than just a headset, because you said it was anything that's measured, right? And so basically, I would say that Maya corresponds to anything that science can do. Right. So it's not just a headset, it's anything that science can do. But that's also true of anything that we can speak using spiritual terms. That's also part of it. Or would you just...
Well, no, I'd like to make two comments. One is at the beginning you said that, before you had your slide, so
Yes.
there's some movement room, but you said that you said Eastern philosophies or something don't claim to have the whole truth.
Okay.
But they also that they have limits. Well, I mean, if you're just only talking about Indian thought, I would say that's directly not true. The thing is that you have lots of different versions which all simultaneously say to have the whole truth, which looks like a contradiction, but that is in fact the situation.
So I want to make sure that they all say that they have the truth?
They do.
They claim that they have the full truth.
They do.
Do you believe them?
No, but I mean, the thing is that it goes that.
Interesting.
Well, the thing is, it all ultimately comes down to karma and the caste system. So it encompasses the whole society, not just the science. But no, the question I was going to ask, you say Eastern philosophy, what about Taoism?
Right. So
Taoism just generates paradoxes. It doesn't make any claims about truth.
right, and in fact, the very first sentence in it is the Tao that can be spoken is not the true Tao.
Well, that's one of many possible translations of Tao, because Tao without fetch on Tao.
What's another possible translation?
Oh, you just open it. There are like 300 different translations of this.
But they're all pointing to the limitations or limitations of
Well,
spoken.
Tao literally means the way. And so, for example, in Chinese painting, you'll often have a pathway going up a mountain. And that's the Tao. Because it's your path to spiritual attainment. Right? So
is
it could
it
be that, or it could be something much more abstract. And even the grammatical structure, it's not quite clear what it means.
Okay.
And
Well, then I'll put my opinion out there. I won't say that this is what they say. My opinion is that anything that you can talk about is not the final word.
Right.
That's my opinion. That if you can say it, then even if you say it with a precise scientific theory, that you are infinitely far away from the truth, because there's an infinite regress of scientific theories that we would ever have to get to try to. So, and I think that there's no exception to that. I think my feeling is that with mathematics, we actually can see the limits of what we're saying. With normal language, we typically can't. And that the spiritual traditions are using language, which is where we need to start, but science takes it to the next step and gives you pointers that are so precise that you now know that's where it stops. This pointer only goes that far and no further. It's an antidote to dogmatism. And it what really formulates your need to move to the next level and get the next theory. So I would love to see a spirituality where we're not talking about what was done 3,000 years ago, it's what we discovered last week. That's the kind of spirituality I would love to see. Yeah.
What is your theory of particle charge, and what are the broader implications in this context?
Yes, so the charge is going to be related to, so it's not going to be, so in physics, right, the charge is sort of a fundamental thing. Again, it's not explained, it's just a fundamental property. In our case, it's going to come out of our fundamental thing are these probabilistic relationships that are modeled in the Markovian. So charge is going to emerge in terms of the long-term behavior of these Markovian chains. So if you start away from this, a long way away from the stationary distribution, you're going to tend to move towards that stationary distribution, and that will appear as though it's a charge. So that's going to be the top level. Does that make sense?
So in a model like the Q that you are representing, is that a sort of mathematical quantification of the qualia that you are talking about? What exactly does it correspond to in the physical world?
In the what world?
In the physical world.
Right. So the idea here is going to be that the probability spaces are the mathematical representation of the qualia, right? So you just literally have, if you know what a probability space is, you have a probability space in which there are all these qualia. The mathematical, so the projection into space-time is going to be as follows. This is a little technical, but you asked a technical question, so.
Okay, sure.
So the way we're going right now, so physicists themselves in the last 10 years, just in the last 10 years, have, they knew that Einstein's theory falls apart at 10 to the minus 33 centimeters. The question is, what's outside of it? And how do you think outside of space-time? And how do you go searching for stuff outside of it? How do you do that? Well, they've done it. They found these things called positive geometries just in the last 10 years. And if you look up positive geometries, you'll see that the European Research Council just put out a 10 million euro initiative. They had their first meeting in February, over 100 mathematicians and mathematical physicists. They found these positive geometries like the amplitude-hedron, associahedron, cosmological polytopes, and combinatorial objects called decorated permutations that classify them. So they found, you find these objects outside of space-time, they project into space-time, they give you the scattering amplitudes for particles like at the Large Hadron Collider. So they can do those computations outside of space-time now, just in the last 10 years. They give you the right answers, and it's much simpler, and you see symmetries that you can't see inside space-time. So they're quite excited. You step outside of space-time, you're finding these geometries that do the computations for you. But here's the problem. Remember 2001, the Space Odyssey, where the obelisk and all the apes are beating on it and they're hooting and hollering. They know it's really important, but they don't know what it means. Well, that's where we are. We found these geometries outside of space-time. We're hooting and hollering, we're pounding on them, they can do the job, but there's no dynamics. What do these things mean? What we're proposing, so what we published last year, we found a way to project our dynamics onto the decorated permutations that they found. We found it, we published it. So we can actually now map onto their structures. We're working, Chetan and I and the team, we're now working to get right down to the positive geometries and then into space-time. So then we would have a map from conscious agents through decorated permutations onto the positive geometries, and then the physicists take us all the way home. So that's our goal.
So at the end, what are you expecting to achieve with all the mathematical formulas and everything? Can you model what we feel?
What will I'll be able to, what we're hoping to explain is first, why is the speed of light constant in all reference frames? No physicalist theory can do that. because they assume that. If you assume space-time, you don't explain that, you assume it. But then we would like to actually get the momentum distributions and the masses. We have a proposal for mass. Mass is the entropy rate. Physics has no, you have to put in the masses by hand for the particles. We can give you the masses by the entropy rates. So in other words, we have tools, as any scientific theory, as you go to a deeper framework, you get tools to explain what the other one can't. So that's what we're after.
Yeah, so we're doing, I'm unfamiliar with positive geometry, so this is going to be a two-part question. Does that encompass theories like the 8 lattice theory or 8x theory? Sorry.
Did you say to rule out?
So this is the first time that I'm hearing the term positive geometries. Does that encompass theories like the E8 lattice theory or 8x theory?
Or 8 lattice, right.
Yeah, and just not a combative question, just to start a dialogue. And I as a response to what you were saying about the antidote to dogmatism,
Right.
Could this type of scientific analysis or mathematical analysis also be a form of dogmatism like spirituality?
Right. It's different from the E8 and lattice theories. Those are still trying to be models of space-time itself. These are positive geometries entirely outside of space-time. So, by the way, they're outside of quantum theory as well. So there's no Hilbert spaces here. So you get Hilbert spaces, you get quantum mechanics and the space-time geometry as a projection of, say, an amplitude-hedron, which could have 1 billion dimensions. Space-time has 4, or 11 if you're thinking about string. So these are massive objects, really complicated. Not as complicated as ours, though. Our Markov polytopes, Markov chains. If you have 50 states in your Markov kernel, the polytope of all possible conscious agent dynamics has more vertices on it than there are particles in the known universe, in the visible universe. So the positive geometries are complicated. Consciousness is far, far more complicated. And your second question was about the mathematics being as dogmatic and so forth. Now, I'm a scientist. I know lots of scientists, and I know many scientists who are just as dogmatic as anybody on the planet. Okay. But as one person, let's see, it was Max Planck, I think, said, science progresses one funeral at a time. Right? And you can do that because each new generation gets new mathematical models that overcome the problems of the past model. Usually the authors of those models have to die before science progresses, but it is the antidote to dogmatism in that sense. Science as a discipline is not dogmatic. Scientific people are, but as a discipline, it weeds it out. And that's the power of having the mathematics. So people are people, scientists are scientists, and their theories only died with them, right? But as a discipline, this is something that I think I want for spirituality, is to have spiritual ideas put in such a mathematically precise framework that we can then say, this idea about Maya, here's my mathematical model of Maya, here's how far that idea goes, and this is where it stops. And now we have a problem here. We need a new, deeper theory about what we mean by Maya. That's the kind of thing I would love to see. Yes.
Sorry, there's a question on the raising hand.
Oh, I'm sorry. I had a little blind spot.
I'm sorry, yeah. My question was, so recently I heard the same statement, science progresses one funeral at a time, Enrico Fermi. That was from a professor called Bob Coca in Oxford, and his point was, he recently proved that English language is same as quantum physics. So there is this nice 34-page paper going on there, but more than that, in your talk, what I finally understood is, not finally, the takeaway you said was, at least now the scientific world will believe us. So my question is then, isn't science something that was changing across centuries? Like until Aristotelian logic came and insisted we need proof using our brain, the Eastern philosophies were, sure, brain is one of the things which you want to convince yourself with, but your self-realization is coming through your meditation and consciousness. So that is where we have been going into the beyond space-time. Right. So do you think that humans got off on the wrong foot with Aristotle and logic, too much importance to brain and not intuition?
Right. So my feeling about it is that yes, if you want to know the truth, you are the truth, and you won't know it by being with yourself and with no concepts. That's my feeling as a scientist. And whenever I want to get new, deeper insights, I usually let go of all concepts and try to go into a space where I can get access to new concepts. So I think of then any words or mathematics or any logic that we use as a way of taking the deep insights that come from this infinite intelligence and desiccating them into logic, language, mathematics. And usually we've only done language. It's only been in the last few centuries that we've been able to actually tighten up our language to have logic and mathematics. And then we get Gödel's incompleteness theorem, which tells us that it's incomplete, right? We actually can use those systems that tell us they're incomplete. And now all of a sudden, we have the antidote to dogmatism that I'm talking about. When we get to that kind of rigor, then we get slapped in the face. Do you believe your words too much? Well, you shouldn't believe your words too much. You are the truth. Any word you say is not the truth. And so that's what this does. But here's the key thing. We know that there's some payoff to being precise. All the technology here is not from verbal, loose descriptions. This comes from mathematics and logic, and none of this would be. So there is a payoff to doing this stuff precisely, not just anti-dogmatism, but actual somehow perspectives on reality are useful. The more precise, the more useful they can be. And that, for me, is a mystery that I'm interested in. I'll just say, this theory of consciousness has no necessary arrow of time. The entropy rate can be constant, so there's no arrow of time. But it's a theorem that anytime you take a projection of it that loses information, you get an arrow of time. So time from this, and therefore evolution of natural selection, is all an artifact of projection, not a deep insight into the nature of reality. Yes?
Oh, wow. Yeah. Back to the positive geometries, I don't know about them either, but that sounded phenomenal, right?
Yes.
Because
It's big.
I'll tell you what is appealing to me about it is that the way you were speaking about it is that it's whole, right? And so I had a visceral reaction when you were talking about desecrating. I was like, oh. I mean, it's like desiccating. Sorry. Yeah. No. I meant desiccating. Sorry. But like this idea that necessarily when we have a whole, that when we divide it up into parts, that it has to always be a reflection of the whole. Like it doesn't, right?
That's right.
And so there's something about being able to measure in our little tiny brains, and even the most intelligent, right? Be able to measure these things always entails breaking them down into certain parts, which then are not reflective of the whole. So we're back at this huge conversation. So I found these positive geometries like very interesting. Like, okay, so that might be fascinating. And then my question to you is going to be, so when you take these projections of that, are they reflections of past data projected forward, or is it creating concepts or projections just in time that are not based on that? Do you see where I'm heading?
Right. So the idea is that time itself is not a fundamental idea. And so that these positive geometries, there is that space-time
Stepping
itself,
outside
both
of it.
space and time, not just space and time
Yeah.
are not fundamental, and we have to be able to think outside of that box. And that's what these positive geometries do. Now, I should say about breaking things into parts. I'm giving an hour lecture tomorrow, I guess in the afternoon. And there I'm going to actually give a much more detailed explanation of all this stuff. And there is on the set of all possible consciousnesses, we have a logic, a brand new logic we're writing it up. It's not been published. I'm going to sort of announce it tomorrow in the lecture. I'm going to present this logic, and it's a non-Boolean logic, and it shows how all the consciousnesses in this model are related, and it's more general than the orthocomplemented modular lattice logics of quantum theory. It's much more general than that. So so in other words, it also says that there's not a one consciousness, there's more this whole consciousness, and it's not a Boolean logic. So again, I'm not saying it's the final word, but now we're starting to say precise things about what we mean by the one or the whole. Here's a logic on it, and so anyway, it's going to be a lot of fun. I'll let you call.
I see one at the end. Right there, yeah.
Okay, just two questions. One, experientially, we can't get out of space-time, and the question is, in what way does that limit us in terms of conceptualizing what lies outside of space-time? And the second is, if I am traveling at the speed of light, and does time stop for me? I mean, I am in a rocket passing at the speed of light. I see planets passing one after the other. So is that not an indication that time is passing and days are going by, in the sense that what I see outside the window are passing planets, even though I'm at the speed of light? So is time moving or not?
So how do we get outside of space-time? And the way that the physicists are doing this and the mathematicians are doing this is,
Let me get a little closer.
yeah, because right, you can't, it's hard. If I say to visualize something that's visualize a three-dimensional cube, you can do that. Now I say, okay, now visualize a four-dimensional cube. Nothing happens, right? Nothing. So how are you going to? You can't. I mean, we're really limited. So how do they do this? It's mathematics. With mathematics, you can actually prove the properties of a four-dimensional cube and crawl your way up with mathematics to understand what a four-dimensional cube is, even though you can't visualize it. Then you can crawl yourself up to 5 dimensions and 6 dimensions, in other words, so you can use mathematics. So that's why this panel, conference have a bunch of mathematicians as well as physicists. And your second question was?
The speed of light.
Oh, yeah, why?
The speed of light, but I see planets going by. So is time passing? Am I getting older?
Well, so at the speed of light, it turns out that distance disappears.
Distance is what?
There is no distance at that. So from here to the sun, we say that it's like 8 light minutes. But at the speed of light, the distance between the sun and us is 0. So the space itself actually collapses. So when you actually that's a singularity of the mathematics. When you're actually at the speed of light, the whole thing collapses.
We actually have the speed of light, what?
The whole space structure actually collapses. There is no distance in the direction that you're moving.
I think one there. We need one question per person now, just so that we
Yeah, I was just thinking in terms of biology of time. But if you're looking at going one beyond time, space-time dimension, but all human beings have their own clocks, internal clocks, and how do we contemplate that? What is the objective measure from physics point of view, and what centers are responsible? Because a lot of psychiatric disorders have different perception of time, subjective time. So how do we look about that, and how do we solve that issue? And in terms of your multiple conscious awareness, is it just meaning to say that all sort of point of views are subjective conscious states, and there is no way of saying which is orderly, which is not orderly in a way?
Right. So good questions. In this theory, the logic that I mentioned that I is not presenting today, the trace logic, it actually shows how to relate all the different perspectives, all the different observers mathematically. And so there's going to be a mathematical answer to your question. And each trace is a different observation, and you'll get a different time parameter. But what we'll have to do is show that we can, for example, get the Lorentz transformation as a projection of this trace logic that we have. So we would show how all the various traces of these consciousnesses are related mathematically, and that when we project into space-time, we get the Lorentz transformation coming out of that. Now, in terms of your own circadian, your own bodily, that's a different kind of thing. That's more about the physiology of different people and so forth. In terms of how it's related to physics is what I'm talking about here. The fact that your perception time might be different from mine is interesting, but that's one reason I mentioned I was trying to get the quarks and gluons and the momentum distributions, and might go, well, why don't you go for the brain? And I mean, that's where the neural correlates of consciousness are. What are you doing inside the proton? I want to go where it's simple. The brain has trillions upon trillions of quarks and gluons. I'd like to first explain 3 or 4 quarks and gluons before I go to the trillions and trillions here. So that's why I'm not going after the brain first. I'm going for what sounds more complicated, but is actually much more easy.
Yes.
Leave it to them.
I'm just afraid our time booked in this room. Unfortunately, we have done our best for it and gone over. But thank you so much, and thank you, Don, and thank you.